Today we are going to look at what is progressions, or in BM, Janjang. Let's see what is Janjang. Janjang merupakan jujukan nombor yang mengikut corak tertentu. A progression is a set of numbers that arrange in a logical and predictable pattern. Please look at these three examples. The first one, 20, 30, 40, 50. From this set of numbers, we know that each of these number is added by 10. Add 10 to 20, it becomes 30. Add 10 to 30, it becomes 40. Add 10 to 40, it becomes 50. So there is a pattern and it is a progression. Second, 11, 9, 7, 5, 3, 1, -1, -3. Minus 2 from 11 is 9. Minus 2 from 9 is 7. Minus 2 from 7 is 5. Minus 2 from 5 is 3. Minus 2 from 3 is 1. Minus 2 from 1 is -1. Minus 2 from -1 is -3. So there is a pattern. So it is a progression. Next, 1 over 2, 1 over 4, 1 over 8, and 1 over 16. The pattern is multiply 1 over 2 to 1 over 2, it is 1 over 4. Multiply 1 over 2 to 1 over 4 is 1 over 8. Multiply 1 over 2 to 1 over 8 is 1 over 16. The pattern is by multiplying 1 over 2. So there is a pattern. It is a progression too. So we will look at Janjang arithmetic, or in English we name it as arithmetic progression. Janjang arithmetic merupakan suatu jujukan nombor dengan setiap sebutan diperoleh dengan menambahkan satu pemalar kepada sebutan tersebut. A mathematical sequence in which every term is obtained by adding a constant to the earlier term. From this diagram, we know that it starts from 1. By adding 2, it becomes 3. By adding 2 again, it becomes 5. By adding another 2, it becomes 7. Adding 2, it becomes 9. And adding another 2, it becomes 11. So there is a pattern where it is by adding 2 chips. So it is an arithmetic progression, which the constant is 2. Therefore, there is a constant, or maka terdapat satu pemalar, iaitu 2. Setiap satu penambahan adalah sebanyak 2. Maka ini merupakan satu janjang arithmetik, di mana 2 ialah pemalar. Pemalar tersebut dinamakan sebagai beza sepunya. The difference or the constant is named as common difference. So where we denote it as D. So how do we find the D if you are given a set of numbers? So 20, 30, 40, 50. If you would like to know whether there is a D, you may use 30 minus 20, 40 minus 30, 50 minus 40 to see whether there is a constant. Yes, it is 10, where it is a constant. So therefore, it is an arithmetic progression. So from the second example, we use 9 minus 11, 7 minus 9, 5 minus 7, 3 minus 5, 1 minus 3, -1 minus 1, and -3 minus -1. And all the results are equals to -2. Therefore, it is a common difference D. it is an arithmetic progression. So here, the main characteristic of arithmetic progression is it is having a D. So next formula for this arithmetic progression is Tn, which we name it as n term or sebutan n. So what is Tn? Tn is derived from the first term is A, which is 20. Second term is by adding 1D to A. Third term is by adding 2D to A. Fourth term is by adding 3D to A. And you will find the result is the arithmetic progression. So from what we derive, when it is one term, it is A. Second term, it is A plus 1D. Third term, it is A plus 2D. Fourth term, it is A plus 3D. So, which means the n term will be A plus n minus 1D. So, if you would like to find further the terms which, for example, 13th term, what will you do is, you know, from what we derive, the 13th term should be A plus 12D. So, you use A, which is 30, plus 12 times D, which is 10, and the results will be 140, where you do not need to list out all the 13 terms in order to get the 13 terms. 13th term. Okay, next, if you would like to find out what is the 41st term, it is A plus 40D, which the A is 20 plus 40 times D, which is 10, and you will get 420 immediately without listing out all the 41 terms. If you would like to know what is the 100th term, you just need to use A plus 99D, which is 20 plus 99 times 10, and you will get it as 1010. So you do not need to list out all the 100 terms in order to get the 100th term. So it is easier. Next, another example, 11, 9, 7, 5, 3, 1, -1, -3, where the D is -2. By using the same method, the first term is A. Second term is A plus 1D. Third term A plus 2D. Fourth term A plus 3D. Fifth term A plus 4D. And sixth term is A plus 5D. So, if you would like to find the 41st term, which is A plus 40D, what you do is only use the A, which is 11, plus 40 times D, which is -2. The result is -69. If you would like to know what is the term of 101, what you do is just use A plus 100D. And it is 11 plus 100 times -2. It is -189. So, that is easy, right? So sometimes we would like to know what is the sum of all these terms. What we will want to know are the sums of the terms. So there is a formula here. Sn equals to n over 2 times 2a plus n minus 1d. The formula is representing the sum from the first term until the nth term. Remember, it's always from the first term until the nth term. Formula ini merupakan hasil jumlah dari sebutan pertama ke sebutan ke n. Okay, let's see how it works. I use back the same example, 20, 30, 40, 50. And the D is equals to 10. If you would like to find S1, which is the sum of the first term, it is also a 20. S2 will be adding the first term and the second term, which is 20 plus 30, and equivalent to 50. S3 is T1 plus T2 plus T3, where it is 20 plus 30 plus 40, where it is equivalent to 90. S4 is equals to T1 plus T2 plus T3 plus T4, where it is equals to 140. If you are requested to find S100 or S50, how are you going to add up all the terms, find out all the terms and adding up them? It is very cumbersome. So there is the use of this formula where we can get the sum from the first term until the nth term easily. See how it works. Instead of using S2 equals to T1 plus T2, we can also use S2 equals to n over 2. N is 2 over 2 times 2 times A plus n minus 1D again equals to 50. You will obtain the same answers but by using formula. So same thing goes to S3, which is 3 over 2 times 2A plus 3 minus 1, which is n minus 1D equals to 90. So you will get the same answer by only using the formula. S4 is 4 over 2 times 2A plus n minus 1D equals to 140. So I hope you understand how does this formula work. Next, same thing goes to 11, 9, 7, 5, 3, 1, -1, -3, which the D is -2. If you are asked to add until 8 terms, where you will need to list out T1 plus T2, T3, T4, and so on until the 8 terms, where it will be this long and the answer is 32. And how about those with higher n? For example, S50, S100, as I said. So what you do is, by using formula, S8 is n over 2 times 2A plus n minus 1D, where it will be the same answer as how you did by listing out. So that was the formula for how to find the sum of arithmetic progressions from the first term until the nth term. So I hope you understand it. And there is actually another formula which is also for sum of n terms. This formula is easier, which Sn is equals to n over 2 times A plus L. What is L? L is the nth term. If you have the first term and the last term together with the n, you can use this formula. For example, 20, 30, 40, 50. If you are asked to find S1, of course it is only 20, which is by adding the first term only. S2 is by adding the first two terms. So it is n over 2 A plus L, which the L is the last term. The last term in this case is the second term. S3 is 3 over 2 A plus L. A is the first term and L again is the last term. In this case, the last term is the third term, where it is 40. S4 is 4 over 2 times A plus L. Again, A is 20 and the L is the last term. In this case, the L, the last term is the fourth term where it is 50. So if you know the first term and the last term together with the n, you may use this formula. Okay, so that is our lesson for today. So what we have learned today is Tn. Tn is the n term. How do we get n term? Is by a plus n minus 1d. And what is d? The d is the common difference, which is a very important characteristic in arithmetic progression. You must have a d in arithmetic progression. The next two formulas that we learn will Sn equals to n over 2 into 2a plus n minus 1d, and also Sn equals to n over 2 times a plus l. So what are they? They are actually the sum of the terms from the first until the nth term, or we say it is the sum of the first n terms. First n terms bring the meanings of it must start from the first term until the nth term. Okay, so that's all for this lesson, which is Janjang arithmetic or arithmetic progressions. We will look at more Janjang or another Janjang, which is Janjang geometry, in next lesson.